As the point immediately following the boiler, the Economizer provides an ideal location for monitoring the levels of excess air in the boiler flue gases. By monitoring certain gases in the boiler flue gas, the air-to-fuel ratio can be optimised so that the maximum heat can be extracted from the fuel. If too little air is applied, the flue gases will contain high levels of carbon monoxide, soot and smoke, increasing the risk of pollution. The presence of unburned fuel is symptomatic of an inefficient combustion process, as some of the energy in the fuel is effectively being wasted. It can also pose a risk to health and safety. If the unburned fuel is ignited, then an explosion could occur with potentially disastrous consequences. Too much air can be equally problematic. Whilst the fuel will be completely consumed, the presence of additional air will increase the flue gas volume and flow rate. This causes heat to be lost via the stack, thereby reducing combustion efficiency. High levels of excess oxygen in the combustion process can also increase levels of produced nitrogen oxides, NOx. Extremely harmful to both health and the environment, these pollutants are tightly controlled by environmental agencies worldwide. To achieve the ideal balance, the level of excess air must be sufficient to burn all the fuel, but not too much to increase the risk of pollution or affect safety. Two gases that provide a particularly good indicator for combustion optimization are oxygen and carbon monoxide. Accounting for approximately 21% of the composition of atmospheric air, oxygen provides an excellent indicator for regulating excess air. However, maintaining the correct level of excess air for combustion can be complicated by variations in the fuel and the air, plus other factors including atmospheric pressure and humidity and the performance of the boiler plant itself. Measuring for carbon monoxide provides an ideal means of compensating for these variations. Carbon monoxide levels will start to increase when the amount of oxygen is insufficient to allow complete combustion. By continually balancing the two measurements against each other, it's possible to achieve and maintain the correct amount of excess air for optimum combustion regardless of any of the variations mentioned earlier. ABB's AZ20 Oxygen and Combustibles Analyzer continuously samples and analyses combustion waste gases to determine the levels of excess air and unburned fuel. Featuring a close-coupled extractive design, the AZ40 uses a sensor assembly mounted on the process wall, with the probe and filter assembly extending into the process gas stream. The sample is extracted from the process and fed through the sensor head using an air-powered ejector. Oxygen analysis is carried out by an industry-standard zirconium oxide cell. For more information about ABB's AZ Analyzer range, contact your local sales representative or visit www.abb.com/measurement.